Check out this video to see what the USD1 stablecoin looks like. Let's see if it has any cool features. If you're not sure what USD1 is, let me explain. Let me give you a quick rundown. So USD1 is the action you take to unfollow, and it's issued by this company called WLFI, World Liberty Freedom, which is actually linked to Trump. It's a blockchain company from their family, and it's designed to be pegged to the $1. Basically, behind it, they've got dollars and US Treasury bonds backing it up. So where's that USD1? Well, there are a lot of chains out there. They mentioned two examples here. One is BSC and the other is Ethereum. But we also know that Solana has it too. This place supports 20 different blockchains, and there's an Ethereum address right here. If we want to find the code, we can look for it at this address, or we can check it out in Dex Screener. I found this USD1. There's an address here. We can also go here, click on the Blockchain Explorer, and then hit that contract. I can see there's a string of code here, but we can tell that this code is for a proxy contract. So let's just take a look at its logic contract. What does it look like? Well, this is our logic contract called a stablecoin. Let's check out this IDE. All right, its main logic code is, it's just that many lines and line 119, but if you count in the dependencies it brings in, including various ones from OpenZeppelin, there's actually quite a bit of content. But the main focus is still on this. The solidity file for this stablecoin is pretty straightforward. It mainly just imports the main ERC20 contract and also a main admin contract. So, this is a pause feature that you can use for the entire contract, a way to pause a subcontract. It's not really complicated stuff. It's worth noting that there's a frozen mapping here, meaning there's a blacklist. So let's hope nobody ends up on that frozen list. Looks like freezing it could cause some big problems. So here it's initialized, and we don't really need to look at this. This is just when the contract is first created, and we need to input a name for it. Also, there's the abbreviation. Other than that, there's not much else. Then there's checking if there's a frozen modifier, and that's used in this transfer. When you're making a transfer, it checks if your account is frozen, and also when you get to the approval part. He's also checking if you're affected by this freeze, mainly those two things. Then moving over, we can see line 40, which is a mint function, and there's an only owner restriction on that. You need to have an admin to mint, and of course, only the admin can handle the burning too. Plus, freezing and unfreezing also require an admin. It's pretty rough how they've set it all up here. It's just mapping, then you get a true, and that's it. If it's a thaw, you just delete it from the list. It's really straightforward. So here we've got a pause, and then there's also an unpause. So if there's a hacker attack or some really urgent situation, the admin can actually pause the whole contract. This feature comes from OpenZeppelin, and since they've already wrapped it up nicely, we're really interested in it. You can check out the logic here. It's not too complicated. That's pretty much it. And then we see the balance in this USD1, which is basically the administrators. It should be a smart contract. So what we're looking at now is the USD1 manager contract. I've already helped translate those notes for you. This looks a lot more comfortable. So if we check out the entire contract, these are all the files it depends on. The only main contract is called Token Governor. Everything else is just references. So we see that he referred to the first 4 points, which are all from OpenZeppelin's security library. Now, in that library, there's something called fine-grained control. What does that mean? It's just set up to separate all the functions, like someone manages A function and someone else handles B function. Just break down all the functions and assign different people to manage them. These roles are basically an array, which means each role, these can all be managed by roles like A, B, C, and D. So, we see that there's a role defined here for minting, another one for the cross-chain bridge, and roles for burning and freezing, covering all the functions. Every function was assigned a role, and then for each role, he could arrange different people to manage the constructor. So based on this calculation, if he has 10 functions, and each function has 10 people managing it, then that adds up to 100 people managing everything. Is that even possible? I think it's not impossible, because if USD1 is really like that, then every day there's minting, burning, or freezing going on that ties into it. Once it gets thawed, there should be a lot of people involved, including him, and there are a bunch of approval steps. So there are definitely a lot of people responsible for managing it. So the design is actually different from what I was thinking before. I was wondering if it could be multi-signature, but then I realized that's probably not the case. Let's move on. Here, the I token introduces the iGovern token, which is linked to the USD1 address. There's also a checker contract here. So even if you have this certification and you go to apply for something, your boss still has to give their approval. So it's all the steps, right? You can't say just one employee can handle it all. We can see all these steps. Look at that mint underlined there. Mint means to create, right? Here they also need to check it, and this process is called check mint. It's about figuring out who the mint is for. What's the amount? Is it a cross-chain bridge? He needs to check all that. If everything checks out, then he'll move on to the next step. If you don't go through him, he's definitely going to mess something up, like destroying stuff, you know? All right, let's move on to line 43. So this mapping is something only admins can use to mint. It's specifically for storing different characters and their wallet addresses, who they are. He's going to take note of that. Once he's done, we'll just skip lines 52 to 58. We don't need to worry about them. Those are some parameters we need to set at the start when generating the whole contract. Lines 63 to 66 are about this one support interface. Seeing interface means it's definitely a connection point, but I haven't figured out how to use it just yet. So, from line 73, I'm checking out how it was set up when the contract first started at line 187. These are all like, get this, get that. Basically, they're just for fetching stuff. The address of a certain character. And these addresses form an array. This could be for the management team, showing data from the back end, figuring out who's actually managing this mint, who's managing this burn. He knows exactly what's going on. Then there's the get token balance. So what's this balance about? What's the balance? Whoever's balance is I token, and I token is a balance of USD1. So whoever holds a balance of USD1, that's what this whole contract code is about. How much USD1 does the address hold? I'm not sure why it holds that amount, but there's an action here for querying it. If it's under 200 lines, it's probably just some functions for execution. The ones you find online are mainly for querying, while for execution, you've got minting, which is all about creating. Also, check out the options for destroying, freezing, and unfreezing. And don't forget about pause and resume. It includes transferring, what's that called again? Transferring permissions. There's also something called emergency recovery for tokens accidentally sent to this contract. Haha, what he means is that some people like to send tokens for this contract, but might accidentally input the wrong address. Just put it into this contract. But if the amount is really big, what do? So he created something like a backdoor to take out those tokens inside. Well, he actually thought it through pretty well. Of course, that includes USD1 too. It's something that can be urgently recovered. So what is this? Let me check it out. It's the tokens to clear the frozen account. I hold 70,000 USD. So I ended up having my funds frozen by this team managed by the Trump family, and they can even destroy the money we have with them. It's that simple, and it can handle batch processing. So for our address, we can send one or multiple staff members, but I can't help but feel like that's a bit redundant. If I'm in this array and I pass an address to it, it's basically the same function. So I feel like he's kind of repeating himself here. This is execution. The token function is basically a way to run a custom function. It sets up a kind of backdoor for the contract so that in the future, if there are any other functions needed, they can be added in easily. You can also use this function to execute other contracts. I think of it as a sort of backdoor. And down here, we have the internal functions. So all the internal functions will have an underscore in front of them when we're writing this kind of contract code. If you have a function and its internal contract is hidden from the outside, it usually starts with an underscore in the naming. This makes it easier to distinguish. Let's take a look at this mint process, which is all about minting. First, let's check out the person we're calling up. Is he a cross-chain bridge or what we call a minting role? So if you're a cross-chain bridge or in that minting role, so those checks won't hold you back. they'll return true. Then you can move on to the next step, and after checking if you're an admin, you'll be good to go. He also has to destroy it, and the second check is to see if your action is authorized. After passing these two checks, then it's really simple. First, you mint one token, which means creating that token, and then you just record that action on the blockchain. That's it. The destruction process is pretty much the same. It's just that token mint got switched to token mint, you know? As for the other stuff, it's mainly about these cross-chain bridges, if anyone's interested. You can also check out the stuff in his address and see how the logic is written. I find it really interesting, especially the role definitions. We can even learn from this contract code. We can roughly estimate how many people are managing that USD1 and how each of them handles it. You can just use the token in this contract as it is.
If you want to learn about developing on the Solana chain and their EVM chain, make sure to follow our channel for more related content. If you'd like to join our community, you can visit our website, where you'll find a link to join our Discord server. See you there.